Hey guys, so we're moving on to Unit 10, and in this first set of notes, we're going to talk about what Unit 10 is all about, and that's the imaginary number I, okay? So the most important thing to grasp from this is what the I actually represents. So when you plug these numbers into a calculator, what happens? If you plug in a square root of -1 into a calculator, you get an error. And if you plug in the square root of -4 into a calculator, you get an error, okay, in your calculator. And that's because you cannot take a square root of a negative number. That's not possible. It's not possible to take a square root of a negative number. So in order to solve these types of equations, we have to use the imaginary number I. So here it is. The imaginary number I is the square root of -1. So whenever we see the square root of -1, or if we can pull out the square root of -1, we're going to call it I. So which makes our solutions to these a little bit easier to solve. The square root of -1 is just I, because it represents I. And the square root of -4, we have to break down a little bit, is the same thing as the square root of -1 times the square root of 4, because 4 times -1 is -4, where this turns into I out front, and the square root of 4 is 2. So I would call this 2I, okay, for my answer. So we have to figure out whether we can take out the square root of a negative number in order to solve. And when we do take out the square root of -1, then we're going to call it I. And that's how you solve these types of problems. So let's try a couple more examples here. So in this example, we have the square root of -9. So remember, the square root of -9 can be broken down into the square root of -1 and the square root of 9. And the square root of -1, remember, is I, but the square root of 9 is 3. So our answer here would be 3I as a final answer there. In the next one, we have the square root of -52. So remember, I'm going to take out the square root of -1 out so that I have an I, and then I'm left with the square root of 52. Now, just like we learned about square roots in the last unit, you have to break down the square root, remember? And think of factors that are perfect squares that come out of 52. So if I look up the factors that come out of 52 that are perfect squares, the only one that I can find that would be a perfect square would be 4 and 13. So since 4 is a perfect square, the square root of 4 is 2. And remember that the square root of -1 is I, then my final answer here would be 2I, pull it out, and I still have the square root of 13. This is how your final answer would look for that one. Okay? And then in this last example, we have a negative on the outside. So first thing that we're going to do is we're going to break down the -12 under the square root. So take out the -1, take out the I, okay? So I'm actually just going to call, instead of saying the square root of -1 now let's get used to it and start calling it I. So I'm going to take out the I, and then I'm left with the square root of 12 that I have to break down. So if I have this negative on the outside, so far I've got an answer of -I that I already pulled out, square root of 12. But I need to break down the square root of 12. That can be broken down into 4 and 3. And the square root of 4 is 2. So I'm going to pull it out. And I've got -2I square roots of 3. There's our final answer for this last one. Okay, so not only do you have to break down square roots, but you also have to take out the I, or the square root of -1, out of each of these square roots. Okay, and this takes a little bit of practice. So the second part of these notes, or this Alex practice, is solving a quadratic equations with the complex roots. So we're still going to use that quadratic formula, and then we're going to have to break down the negative so that it has a complex root, which is an imaginary number in it, okay? So look at this. The equation that they give you, we have 3x squared plus 2x plus 5 is equal to 0. So you've got 3 is your a. Remember how it goes, a, b, c, in our equation of a quadratic. So 3 is your a, 2 is your b, 5 is your c. So if you recall the quadratic formula that we did over and over again, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, okay? And then from here, we're going to plug in all of the values that we just found. So remember, b is 2, a is 3, and c is 5. So let's plug in all of those numbers and do our arithmetic here. So we have negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 3 times 5 all over 2 times 3. Okay, let's solve what's under the square root first. So we've still got the negative 2 plus or minus square root of 4 times 3 is 12, and then 12 times 5 is 60. Okay, so you have 4 minus 60 here, which is going to get you that negative number, which is what we want for a complex root, all over 2 times 3, which is 6. So 4 minus 60 is negative 56, and I have to break down that square root so that it has a complex number in it. So if we go ahead and give ourselves some room to break down that square root, remember we have the square root of negative 56, and I'm going to do it over here. Break it down into I and the square root of 56, and then you have to think of perfect squares that are going to come out of 56. So let's see, we've got 4 and 14 come out of 56. 4 is a perfect square, so the square root of 4 is 2. So if I put all of this together, I can rewrite the square root of negative 56 to be 2i square roots of 14. So then when I go to write my answer of my complex root, I have x equals negative 2 plus or minus, which means we have two answers here, 2i square root of 14 all over 6. And those are your two answers to your equation written as complex roots or as imaginary numbers. Okay? So take your time with this. You got to recall the quadratic formula, and you have to break down those square roots so that you can pull out the negative 1 or the square root of negative 1, which is your I. So make sure you just pull out that I and then break down your square roots as you learned how to do in the previous unit. As always, let me know if you have any questions. Good luck.